Welcome back. Today we're going to talk about slope of a line. Okay, so let me make sure you can see all of this here. Okay, so the slope of a line or the rate of change of a line comes from a natural question. We might wonder how fast are variables changing in a graph, like how fast is x changing according to y? And we may wonder this in order to compare one graph to another. So the answer to this question, we use what we call rates of change. Okay, a rate of change is a ratio, right? It's a ratio, so it's like a fraction of the amount of change of the dependent variable or the output. This is also the y variable, to the amount of change of the independent variable. So again, you're asking how fast does y change in relation to x, or how fast does the output change in relation to the input. All right, so the rate of change is always the change of dependent variable or the output or the y variable over the change of the independent variable, which is the x variable. Okay, when the rate of change in a relationship is constant, like so right now, what we're looking at is a rate of change that's constant. So when this rate of change is constant, any segment of its graph has the same steepness. When that is the case, what you end up with is a line. So if the amount of change to the y variable to the in relation to the x variable always remains the same, then what you actually have is a line and not a curve. What distinguishes a curve from a line is that the rate of change of a curve between any 2 points is always changing, whereas a line, it's always steady, right? So when we have a line, when we have a constant rate of change, when the rate of change is not itself variable, right? When the rate of change is not changing and it's constant, we call that the slope. All right, so the slope indicates a constant rate of change, and what we have is we have a line here. Okay, so we're going to go on to how to calculate rates of change in just a second. But what distinguishes a line from a curve is that a line has a constant rate of change, and we often, instead of calling it rates of change, we call it the slope of the line. Okay, the slope formula. Now, the slope formula is equivalent to the rate of change formula. It just uses the coordinates of the points. So for us, we are going to use, so here are the points along this line. We're going to use the coordinates x1 and x2, and sorry, x1, y1, and x2, y2. So what this indicates is this little subscript, that's called a subscript, that indicates that is the x coordinate of the first point. This is the y coordinate of the first point. This is the x coordinate of the second point, and the y coordinate of the second point. Okay, so here, if we take 2 points, we could consider this x1 right here and this x2, and this y1 here and y2. Okay. Now the slope is going to be calculated as the difference between the y coordinates as a ratio to the difference between the x coordinates. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's actually how you read this script here. It's a subscript. So we say x sub 2. Sometimes we refer to this formula as a variable m. So we say slope is equal to m. I'm not sure where the m comes from, but maybe it's some German word, because a lot of the mathematics that have been translated for in the English language has come from Germany. So perhaps it stands in for some German word that means steepness, but I'm not sure. I'm just speculating here. But m often stands in for slope, and it certainly is going to for the first level of algebra. Okay. Sometimes we refer to the slope formula using a symbol called delta. Delta is a Greek letter, so this is a screenshot of the Wikipedia page for the Greek alphabet. Delta is this letter right here, so it's a capital letter in the Greek alphabet. This is the lowercase delta, this is the uppercase. And delta has been used over the years by mathematicians and scientists to represent change, okay? So often what we do is instead of saying, instead of using the change formula, we shortcut it, because really what we're doing when we're taking a difference is we're looking at the changes between the y coordinate and the changes between the x coordinate, and then we're finding a ratio. So to indicate this idea of change, we can use this Greek letter delta, and what we do is we represent it as, sometimes it's called delta y over delta x, okay? So sometimes it's standing in, this right here is standing in for your y2 minus y1. And this right here is standing in for the x2 minus x sub 2 minus x sub 1, because it's the change of the y coordinate. So sometimes it looks like this. Okay. Another way that you might hear slope referred to as it's like a mnemonic device when you say rise over run. Okay, because rise indicates the change in the y coordinate, because our y coordinate is our vertical component of our coordinate pair. So it's the change in y over, now run is our horizontal, the change in our horizontal component. So this is our change in x, or delta y over delta x. Okay, so these are three different ways of saying the same thing. So you can have the slope formula, which really just helps you because, you know, the formula is a way to plug in numbers and actually derive a value for this. Delta y and delta x, whoops, I bolded the wrong face of the triangle, or I bolded the wrong side of the triangle in the last problem here. This should be bolded on the right side here, technically. Okay, so sometimes you see delta y over delta x, and sometimes you see rise over run. These two are more memory aids or mnemonic devices. This is actually just the formula to remember in order to derive the value. Okay, so finding slope from a graph. So remember, slope is just the indication of how the steepness of the line. Okay, so let's use this idea of rise and run, because on a graph, it's a little bit easier to find the slope than if you're just given 2 points. Okay, so the graph shows the rate at which the water is leaking from a tank. The slope of the line gives the leaking rate, right? So once we find the slope, it's the leaking rate in gallons per minute. Find the slope of the line. So the first thing that you want to do, and they actually already gave you these 2 points, but if you didn't have these 2 points, you're looking for 2 points that fall along the intersection of two coordinate grid lines, okay? And that's because when you get the values of the coordinates, here it would be 4, 3, these values are going to be integer values, okay? If you picked a point like this point on the line, then, or this point, there, you know, it's going to be a little bit harder. That's like 6 point something, and this is like 4 point something else. It's a little bit harder to determine exactly what the coordinates are for a point that doesn't fall along the intersection of two grid lines. So for these are good points to pick because they fall along the intersection. Okay, so you could, now that I've discovered these 2 points, we have 8 over 6 and 4 over 3. You want to write them vertically, okay, because that will help you identify your x coordinates here and your y coordinates here. Okay, so I'm going to show you actually 2 methods of finding it. Okay, let's use the formula. The slope is equal to y2 minus y1 over x2 minus x1. So let's say that this is x2 and y2 and x1 and y1. Okay, this is the x coordinate of the second point, y coordinate of the second point, x coordinate of the first point, y coordinate of the first point. Okay, so let's plug these values in here. So we're going to have 6 minus 3 over, right? This is 6 minus 3 over 8 minus 4. That's 3 over 4, or just 3/4. So I'm going to leave it as a fraction, 3/4. Okay, that's one way of finding it, using the coordinates and the formula to find it. Now, another way of finding it is using the idea of rise over run. This is very easy if you have a graph, because it's easy to count the rise. So pick one point right here and pick the second point and figure out how much did it vertically rise to get from this point to this point. Well, you want to make a right triangle here, okay? And you're going to find the sides of this right triangle. This is up 1, 2, 3, so positive 3, and we ran across 1, 2, 3, 4. Okay, so our rise is 3, our run is 4. If we make a ratio of rise over run, it would be 3/4. Okay? Now, a natural question that you might ask is, how did I determine, in the last example, how did I determine that this was point 1 and this was point 2? What if I had switched them around? And the spoiler alert is going to be, it's not going to matter. Okay, so if this were point 2, then this were point 1, let's go ahead and get the coordinates again. This is 8, 6. Right here, and this is 4, 3. So let's align them vertically one more time. So we have 8, 6, and 4, 3. Okay, and our slope is going to be y2 minus y1 over x2 minus x1. Oops. And so here, this is going to be our x1 and our y1, right? So x1 and y1 here, and this is going to be our x2 and y2. So when we plug these values in, we're going to have 4 minus 8 over 3 minus 6. And that's equal to negative 4 over negative 3, right? This is negative 4 over here over negative 3. Well, the reason why I say it doesn't really matter is because negative 4 over negative 3, actually a negative divided by a negative determines a positive. Oh, whoops, I actually switched around the x and y coordinates. So here, I had just gotten the reciprocal, so I knew that something was wrong here. So let's go back here. This should be y2, so it should be 3 minus 6 and 4 minus 8, which gets you negative 3 over negative 4. Phew. Okay, and so negative 3 over negative 4, actually when you simplify it, just gets you 3 over 4, because another way of thinking about it is you could actually factor out a negative 1 for both the numerator and denominator and then cancel it. Or thinking about it as a negative divided by a negative gets you a positive. So the slope gets you, again, 3 over 4. So it didn't matter which point I chose for point 1 and point 2, as long as I stuck with determining my y2 and my y1. So as long as if I start with the bottom coordinate and I do the bottom coordinate minus the top coordinate, I have to do the same with the x values, the bottom coordinate minus the top coordinate. Whereas here, if I start from the top coordinate, I go top minus bottom over top minus bottom. So it doesn't matter what point I choose as long as I stick with the same format for the difference of y over the difference in x. Okay? So again, here, if I choose my rise over run way, from point 1 to point 2, well, I drop down by 3, so that's negative 3. The change in the y position is drops down, so I indicate that with a negative number, and I go over to the left by 4, so that indicates a negative 4. If I'm going left, that indicates a negative. Okay, if I'm going down, that also indicates I make the sign of my change negative, right? So negative 3 over negative 4 would also have determined the slope as 3 over positive 4. Positive 3 over positive 4. Okay, how do I determine slope from a table? So given a table, remember tables are just coordinates in disguise, right? So this is the coordinate 1 comma 4.5, and this is the coordinate 3 comma 13.5. Okay, doesn't matter which 2 points you could choose. Actually, if I wanted to, I could choose these 2 points because they're integer values. I could choose these 2 points. I could choose 1 and 6. I could choose 3 and 4. It doesn't matter which 2 points I choose, because if it's a line, the rate of change is constant between any 2 points. So let's actually go ahead and choose the first one and the last one. Okay. So here I can go, so my y values, let's choose this as your y2, 27 minus 4.5, because your slope is y2 minus y1 over x2 minus x1. Okay, so you can label these y2, x2, y1, x1. So this would be 27 minus 4.5 over, let's see, we'd have 6 minus 1. Okay, so that's over 5. 27 minus 4 is 23, minus a half is 22.5. So it'd be 22.5 over 5. So we could ask ourselves how many times is... So it'd be a little easier if I used these 2 coordinates right here. So strategically I could have done that, but let's just go ahead with this method. That goes into it 4 times, so that's 2.5. Doesn't go into it any time here. So that would be 0. Or 5 doesn't go into 2. Oh, actually, sorry. 5 goes into 2.5, 25 rather, 5 times, because I don't have to bring down the decimal. So that's 5 here. So it's 4.5, and that would be 25, and we'd subtract to get 0. So 5 times 5 is 25. So this would be 4.5. So this would be 4.5. But what you really want to do is you don't want to leave the slope as a decimal. So I'm actually going to turn this into the fraction 9 over 2. And that's because we want to preserve the idea of rise over run. All right. And this will make perfect sense when we start to graph using the slope and an intercept. But for right now, the rule that you need to remember is if you're left with a decimal, I want you to change it into an improper fraction. Or if you get an improper fraction, don't go back to get a decimal. Okay, you either leave slopes as integers or you leave them as fractions that are reduced. Okay, so our slope here is 9 over 2. Now, you could ask the question, well, what happens if you had chosen two different points here, so I've sort of marked everything up here. What if I chose these 2 points right here? Okay, well, I would have gotten 27 minus 18 over 6 minus 4. So 27 minus 18 is 9, and 6 over 4 is 2. So I would have gotten the same thing because it's a constant rate of change. Now, since I chose the first point and the last point, I ended up having to reduce it. If I choose 2 points that are next to each other, I decrease the likelihood of me having to reduce it in the end, but at the same time, it's the same thing, okay? Okay, if we try to find the slope of a vertical line, we're going to run into something kind of strange. So let's pick a couple points here. This point right here is negative 2, comma, 0. And this point right here is negative 2, comma, 4. Okay, so if I line them up, negative 2, 4, and negative 2, 0, all right, what's going to happen is I'm going to get, let's say, 4 minus 0 on top, okay? And I'm going to have negative 2 minus negative 2 on the bottom. So 4 minus 0 is 4. Well, negative 2 minus negative 2, let's use keep change. It's going to be negative 2 plus 2. Well, that's going to get me 0, okay? And 4 divided by 0 is actually undefined. Okay, what does that mean? All right, well, an undefined slope is a vertical line. And why does that make sense? Well, think about the slope, returning to the idea of slope as steepness. If the slope is very, very steep like it is with a vertical line, right, it's infinitely steep. There's not even like a way to measure the steepness, then the steepness is undefined. Okay, so when you have a vertical line, which means that the denominator of your slope formula is going to be 0, it is undefined. Okay, if I find the slope of a horizontal line, I'm going to get something a little different. So right here, this point is 1, comma 4, and this point is it's 5, comma 4. So if I line them up vertically, 1, 4, and 5, 4, and I use my slope formula, the top is going to be 4 minus 4, and the bottom is going to be 1 minus 5. So it's going to be 0, let me do it on this side, 0 over negative 4. Well, if 0 is in the numerator, that's totally fine. 0 divided by negative 4 is 0. Okay, so a horizontal line has a slope that's equal to 0. Now, this is very different than the slope of undefined. Think about a horizontal line. There's no steepness to a horizontal line. So the slope is 0. There's 0 steepness. So the slope of a horizontal line is 0 because the steepness is 0 steepness. A horizontal line just keeps going on and on forever, so there's no inclination to a horizontal line. Whereas a vertical line right here, the slope is undefined because it's infinitely steep. So those concepts are very different from each other, okay? All right, so there's two different ways of finding the slope of the line. If you want to use the algebraic method, you can use this right here. You can just go ahead and use the formula. If you want to use the geometric method, you could actually go and, if you had some graph paper near you, you can plot it right here. So 0, 5 and negative 4, 3. You can plot the 2 points and actually use the concept of rise and run. So let's go ahead and do this real quick. y2 minus y1 over x2 minus x1. And if this is point 1 and point 2, then you could work from the bottom to the top here. 3 minus 5 over negative 4 minus 0. And this would be negative 2 over negative 4, which gets you 1 over 2. It reduces to 1/2. Whereas here, this would drop down by 1, 2, so down by 2 and left by 1, 2, 3, 4. And again, you get that negative 2 over negative 4 to get your rise over run, and that reduces to 1/2. So there's two different ways you can do that, okay? And I want to leave you with this picture here. It's a memory tool, a mnemonic device that helps you remember slopes. So if a line is going up, the slope is positive, right? If a line is going down, the slope is negative. Okay, if a line is vertical, the slope is undefined, like this U standing for undefined. And if a line is horizontal, the slope is 0. Okay, so it's a little bit of an easier way to remember, especially the difference between an undefined slope and a 0 slope. So it's like the slope man is winking, right? So his eye is closed on, let's see, it would be his left hand side. So why don't you write this down in your notebook as a way to determine the difference between, especially undefined and zero slope. So that's it for the lesson today. We covered a lot of ground. We talked about slope. We figured out 2 different ways to calculate it. We talked about zero slope and undefined slope. So congratulations for making it all the way through this lesson. And I will see you later on.